then we call field effect transistor, FET, then MOSFET, then silicon control detector, SCR. All this thing we'll talk when we talk. SCR and all we'll be talking about triac, all those things we'll talk when we talk about hybrid vehicle, electric vehicle, motor control, no? That time we'll be talking in the subsequent. This is the part of this one. But some portion NP and PNP diode also coming in the +2 syllabus itself. My son studied. Because I saw, no, because I used to look in this book sometime if he has any. So in +2 he studied. In CBS syllabus also it is there. In most of this one, physics nowadays it is there. The last chapter, electronic device, a transistor diode, something like that. And also, in fact, they have, I saw gates, correct, and gate, or gate, detail a little bit also, something I saw. Okay, we'll start the class. I think time up.
Sir, yes, sir. Already joined, sir. People are joined. Please, sir.
Yeah. So yesterday we were talking about the transistor. Specifically, we started what is a transistor. It is a three-terminal, three-layer semiconductor device which can amplify the electrical signal. The electrical signal input is given to the base terminal, which is called as base current IB. That will be multiplied by beta times we call as the current gain of the transistor. That is decided by the manufacturer of the transistor. You cannot change it. While selecting transistor, you have to select the appropriate gain value. The commercially available transistors having current gain, which is called a beta, can vary from 10 to even 1 lakh. So yeah, depending upon how much amplification you have to do, the base current should be amplified. You can select the transistor having specific beta, maybe 100, 200, 5,000, 10,000, 20,000, 50,000 also. That's what I told yesterday. And if you want to make the transistor work, you have to supply voltage to all the three terminals: base terminal, emitter terminal, collector terminal. That's what I told you yesterday, that it is called a biasing the transistor. So again, I told you about this. The NPN transistor and PNP transistor both are shown in this PPT. Left side I have the NPN transistor. Yeah, both the transistors require two power supplies. Already yesterday talked about it. So you can still know that. One power supply is called collector to emitter supply, which is called as VCE. Please know that VCE in some books they put just VC or some other terminology also, general terminology. This what I'm talking is generalized terminology. Suppose if you see some textbook, please note that there are more than 10 to 20 or 30 or 100 textbooks talking about transistor written by different authors. Each author cannot use the same this one. Okay. So copyright, book, copyright, all those things. Sometimes somebody writes VC, somebody writes VCC or something like that. VSS, something and all they use. Don't worry. But basically, you need two power supplies. Okay. One power supply is called a collector to emitter. Please see that in NPN transistor, emitter should be connected to lesser voltage compared to collector. No doubt. The voltage at the collector terminal should be higher than the voltage at the emitter. That is very important. So now if we take a battery, negative is lower than positive terminal. For example, I take a power supply VC, the power supply which is 10 volts. Please note that this symbol represents DC voltage. If I show a battery symbol, it is called as DC voltage. Battery also is a DC power supply. DC power supply means you know that voltage should remain constant with respect to time. X-axis is the time, 0 to infinity it goes, time axis. Y-axis is the voltage amplitude. Now, if we say lead acid battery, 12 volt means the voltage. So now I measure T equal to 0 second, it is 12 volts. Even I measure 10 minutes after, 20 minutes after this one. As long as you don't draw the power from the battery, the voltage should be remain in the lead acid battery 12 volts. So if the voltage remain constant, it is called as DC voltage or direct current. Correct? DC double direct current. So instead of that, I know you know that you will be knowing, but still I just wanted to show that while biasing the transistor, you cannot use AC voltage. That's why I'm explaining this. Correct? You may be knowing basics. Why I sir is trying to explain. Correct? Many times student in the exam, if we ask, you write something wrong also. That's why I'm telling. Even the electronic students make mistakes. Okay. So if I do AC voltage means the x-axis is a time axis. 0 to time is going. Y-axis again voltage, also called amplitude. Now this is called as 0 volts. With respect to the top side, you call plus voltage, bottom side is negative voltage. If I say sinusoidal AC voltage, what is a 50 Hz? The voltage is varying like the sinusoidal fashion repeatedly. correct? So this is called a positive peak and this is called as negative peak. With respect to zero voltage, voltage increasing sinusoidally reaches a maximum positive value and again comes down, reaches zero. This is called a positive cycle. Yeah, AC voltage means it should have positive cycle and as well negative cycle. Okay, and then from 0 volts, next half cycle is called a negative cycle. The negative cycle voltage from 0 volts goes to minus peak. This is called negative minus peak voltage. Go to maximum this one. Again, it comes to zero. This is called as one cycle. If we say AC voltage, it should, with respect to 0, it should goes to positive cycle, negative cycle. Why I am saying is, for example, I may have a voltage like this. It is also varying sinusoidally. This is 0 volts. This is plus voltage. This side is positive voltage. Negative side, no voltage. Correct? It is not there. This cannot be called as AC voltage. What this is called? It is a called as DC voltage or pulsating DC voltage. It is called as pulsating DC voltage because voltage is varying one side only. 0 to, it can go to 1000 volts or infinite volts, but it's not coming negative side. This cannot be called as a true AC voltage. Again, remember, that's why, correct? Because I asked one electrical student, he said this is also AC voltage. This is not AC voltage. It is a time varying DC voltage or pulsating DC voltage because instead of that, for example, I have this one, voltage is varying like this, negative side. This is 0 volts. This is positive side. This is negative side. 0, it goes to negative. Again, it is a pulsating DC voltage, not AC voltage. AC voltage means with respect to 0 volts, it should have positive side, negative side. That is what the true AC voltage. Sometimes people get confused. Okay, that is one thing. I am explaining that's one thing. Fine. Now, if I wanted to make the transistor to work as an amplifier, I need to supply two voltages. We are talking NPN trans already. We talked yesterday. It need one power supply VBB. That means with respect to ground. Correct. Please know the emitter is connected to ground. The battery minus of the first power supply called collector power supply. Other one is called base power supply. Both are connected to ground. That means emitter, the negative of the VBB power supply and VCC all are connected as a common ground, which is called as 0 volts. This is how you have to connect. Then the positive voltage of VCC should be connected to collector terminal of the NPN transistor through a resistor. You cannot directly connect. If you connect, there's a problem. That I will tell later. You have to connect through resistor, which I call RC. Already I told you, it's called current limiting. Collector current limiting resistor. Correct? Why? Means the current from the battery, I am showing a current flowing from battery plus to which battery? VCC power supply through the resistor and enters in the collector terminal and circuit is closed. This current is called collector current IC. This current is limited for each transistor. The manufacturer says IC, what is maximum current? They call IC max, no doubt. Any transistor, this is important specification. What is the maximum current through the collector can enter, come out of emitter and circuit is closed. That is called IC max. They say 100 milliamps, 10 milliamps or 1 amps, 10 amps, 100 amps, depending upon the size of the transistor, power dissipating capacity, all those things. So IC max is one of the important parameter that is decided by the manufacturer. Correct? And you similarly, as I told, beta is also called current gauge that is decided by manufacturer. Again, another important parameter, what is the VCC collector supply, which you are giving between emitter and collector, that is called VCC max. Note down, these are important parameters. Data sheet, the manufacturer will tell. Then next important thing, yesterday I told VBB max. Then third one is called IB max. That is nothing but base current. This current from the VBB power supply through the base resistor, they call base current limiting, through which it enters the base terminal, comes out at emitter terminal, then circuit is closed. Already we discussed it yesterday. Just for the clarity and quickly, I'm just saying. So there are two power supply needed. One is for biasing the base, other one is biasing the collector. How it should be connected for NPN transistor? There are one power, the plus of the VCC will be connected to collector through RC. Similarly, VBB plus should be connected to base. Emitter and as well as the negative of both the power supply should be connected ground or 0 volts. This is NPN transistor. If you use a PNP, same. Again, it has a collector, it has a emitter, it has a base. Okay. In PNP transistor, if you want to bias, again you have VCC, and VCC has plus and minus terminal. In this case, PNP transistor, negative terminal of the VCC should be connected to collector of the PNP transistor, negative terminal, through RC. Correct? So the current from this battery will go like this. It will flow like this. This is called as IC. Okay. And it will circuit is closed. This is called collector circuit. Similarly, VBB, the positive should be connected to ground. Negative of the battery will be connected to RB, base connected to this one. So IB current is flowing. Okay. So current will flow, the circuit will be closed. Only different what I told yesterday, in case of PNP transistor, the base voltage is negative, emitter voltage is positive. With respect to base, emitter voltage is positive. Similarly, with respect to emitter, collector voltage is negative. Base and collectors are connected to negative of the two power supply. The positive terminal of both the power supply and emitter of the PNP transistor is connected to 0 volts. Please know that many times people get confused. Positive voltage, because we are connected commonly, correct? So this is taken as reference. This can be, even battery positive can be considered as a 0 volts with respect to this voltage. For example, this is a 10 volt battery. I can say like this: with respect to negative terminal, positive terminal is 10 volt positive. Instead of that, I can say that with respect to positive terminal, negative terminal minus 10 volts. This less by minus. So it is called as relative. In electrical thing, we call relative terminology. With respect to positive terminal, negative terminal is minus 10 volts or minus 10 volt lead acid. Otherwise, I can say that with respect to negative terminal, positive terminal, positive 12 volts. Same thing only. Okay, this is over. Now, we discussed yesterday itself. Already we have talked how to calculate IB. The formulas are given. I told you VBB is called the base voltage. VCC is a collector supply voltage. And there are another voltages there. Voltage between the base terminal. This is base terminal. This is the emitter terminal. Between these two, there's a voltage. That voltage is called as VBE. No doubt. Base to emitter voltage. That means I take a voltmeter, connect the two terminal plus and minus. I put across this. In that case, there will be a voltage. That voltage is called as base to emitter voltage. Please note that this voltage is not called a VBE. It is called VBB. This is called as bias voltage, base bias voltage. That's why I call it so. Similarly, this voltage is called as collector bias voltage. Okay. Then this is called a VB, between base and emitter. Similarly, in collector circuit, between the collector and emitter, there's a voltage. That is called a VCE substitute. That means voltage between collector and emitter terminal. So this voltage is different from VCC, which is called a collector bias voltage. Similarly, VB is different from VBB, which is this one. Note down. Why I am talking all these things? Because when I wanted to calculate what is the current flowing through the base terminal to emitter terminal, this is circuit is closed. This current is called IB. To calculate IB, the formula is given here. How did you get it? Using this one. First thing is this circuit is base bias circuit. In base bias circuit, what is input voltage? VBB. This is input voltage. VBB minus the voltage across this resistor. Okay, that is called as base currently. The RB is nothing but I call as VRB. VRB equal to IB into RB. Note down. Okay, this is what this. Then across this I have voltage that is called VBE. Okay, that is base to emitter. So now this circuit, if I want to analyze according to, note down, according to Kirchhoff's voltage law, short form is called KVL. In electrical circuit, this one, this is very simple equation. Don't say that very complex. According to Kirchhoff's voltage law, the supply voltage equal to voltage drop across this resistor and voltage drop across the base emitter junction. So supply voltage VBB minus IB into RB is nothing, voltage across this resistor minus VBE between base and transistor equal to 0. This is the equation number 1. From this, I can always get the formula. I want to know what is IB, how much base current I can supply. That I want to calculate. That can be computed using IB equal to supply voltage VBB minus the voltage drop occurred in this equation itself, correct? So this equation, from this I am deriving this. So IB is going this side, correct? IB is come to left side, remaining things are going to right side. I am retaining, and VB, all those things go to this one except IB. In that case, VBB minus VBE divided by this goes to denominator, RB equal to IB. This is how you calculate the base current. Note down this formula. We are going to work out one simple problem today. Okay, to understand, as Arnason asked, each important problem, I will solve one problem so that you can expect similar problem in the exam. So we have now decided how to calculate IB. Okay, now I will tell you how do you know what is RB? VBB, I know. I am saying again, I am giving VBB equal to 5 volts. That is known, correct? And IB only I am going to calculate. And we know that when transistor is conducting, which one? The base to emitter, the current IB has to flow means VBE should be 0.7 volts. It should be greater than 0.7 volts. Now, if that means VBE can be taken as 0.7. Please note that VBE will be 0.7 only, note down, only when VBB is greater than 0.7. This is an important condition. This is called as an important condition. Now, I told you the current IB will flow. IB will flow only when VBB is greater than 0.7. Minimum greater than 0.7. That means it should be 0.8 volt, 0.9 volt, or at least 0.75 volt, something like that. Then only the current IB will flow. If IB flows, I will say the base emitter junction is forward bias. Base emitter junction. That means current from this power supply will enter through the resistor into base terminal, complete circuit will close. That happens only when VBB is greater, that is supply voltage. Again, I told you yesterday or today also I am repeating, this is called as input voltage. Input voltage to transistor. Okay, so if I vary the input voltage, I told you for this transistor, each transistor VBB will be given. What is the maximum value it can be? Okay, VBB can be varied from 0 to 5 volts, where the 5 volt is represented as VBB max. If you see the data sheet of the transistor, it will mention very clearly what is the maximum base voltage you can give it. Okay, that means I can vary the VBB to this is VB max. 0 to 5 volts I can vary. Now, if I am varying I am giving 0 volts, IB will be 0. If I give 0.1 volts, IB will be still 0. If I give this is 0.2 volts, 0. If I give 0.5 volts, still 0. 0.6, still 0. I give 0.7, maybe IB can flow. I don't know, very small quantity. But if I give 0.8 volts, VB equal to that VBB equal to 0.8 volts, automatically IB will flow. How much IB will flow? That is what you are going to compute using this. Note down. That means if my VB is lesser than equal to or lesser than 0.7, IB is 0. In that case, I will say that my base emitter is not conducting. IB is 0. Already yesterday I told you IC. IC is nothing but output, which is the current flowing from VCC into the collector terminal and completes. This is IC is called as output of the transistor. IB is called as input of the transistor. IB will flow only when VB is greater than 0.7, at least 0.8. But how much it can go? It can go up to 5 volts. That's what the manufacturer has told. So only when VBB is greater than 0.7 up to 5 volts, IB will be flowing inside the transistor base enters. Then only the transistor will conduct. What is the transistor conducting? Then only IC will flow. only when, note down, only when IB is greater than 0, IC will flow. IC will flow from where? From this power supply through the resistor to collector and comes out. Circuit will flow. Okay. So then only I say that my transistor is working or conducting. Only when IB flows, IC will flow. If both are flowing, I will say transistor is conducting. Otherwise, I say transistor is off. That means it is not working as an amplifier. It is not working. That means this is important condition. Okay. So now, if I give, for example, VBB equal to 2 volts, what happened? VBB is 2 volts, and I know that my RB equal to 1000 ohms. Okay, already told yesterday. Now I can calculate. I can calculate IB equal to what? This is known 1000 ohms. VB equal to 0.7 volts. Again, once transistors start conducting, you know that VB is always 0.7. That means when VBB is greater than 0.7 up to VBB max. What is that? That means VBB can vary from 0.7 to 5 volts. If it happens, my VB is 0.7 only, note down. Correct? So this becomes that means in the formula. Now I said I want to calculate what is the current flowing when VBB equal 2. Okay, that means 5. Sorry, this is 2 minus 0.7 divided by 1000. So that is IBB. Instead of that, I am supplying 3 volts. Let me clear everything, then you can see it. Now I am supplying VBB equal to 3 volts. What is the IB? IB equal to VBB minus VBE divided by RB. RB already told this is 1000 ohms. We know that. Correct? But RB also we have to calculate. Next slide, I'm going to talk about that. So IB equal to VBB, that is what is the voltage you are supplying. Currently, you can vary from 0 to 5 volts, but I am giving 3 volts. That means this will become 0.3. We know that what is VBE value? VB is always 0.7 if VB is greater than 0.8. 0.8 to 5 volts. So that means I will substitute this equal to 0.7 divided by 1000. That is going to be 2.3 divided by 1000. So many amps. Okay. So for example, if I supply VBB equal to say 4 volts, what is my IB? Same. 4 minus 0.7 divided by 1000 is going to be 4.3 divided by 1000. So many amps. This is how you calculate IB. Now that you know IB, correct? You can calculate IC. IC is nothing but collector, which is output, which is nothing but beta times IB. Correct? Beta times IB, I told you. I told this transistor beta equal to, for example, 100. Correct? Then what happens? For example, in this case, the IB beta is 100 multiplied by, what is IB? IB is nothing but VBB minus VBE divided by RB. If you multiply, automatically you get result. So now I know that my transistor is working as an amplifier. Okay. So any doubts, get clarified. Because you can expect problem.
No,
okay.
no, sir.
Okay. Next one is, this is to compute the IB. How will you calculate? I can calculate IC equal to beta times IB. Okay. That is one formula. Another one, we can calculate using another formula. This circuit, correct? I am giving VCC equal to 10 volts. Correct? This is called supply voltage. According to KVL, Kirchhoff's voltage law, what it means? Supply voltage minus the voltage drop across this resistor. What is that resistance? The current is called IC. I call this, the voltage is VRC. That means voltage drop across this is nothing but IC multiplied by RC. Already you know IC. Correct? IC you are calculating using this. Then I can calculate what is the voltage across the resistor. Minus VCE. VCE is nothing but voltage drop across the collector and the emittent terminal. This is called VCE. Okay. This is this one. Now we know that VCC, I said this is 10 volts. Already you, for a given base voltage, for example, you given 4 volts here. Correct? You are given 4 volts. Automatically you calculate what is IB. From that you already calculate IC. That means the IC multiply by RC. For example, the resistor is known. This is, for example, 100 ohms. RC equal to 100 ohms. Then IC multiplied by RC. How did you get IC? From this. First thing is you calculate RB as IB using this formula based on what is supply voltage and what is RB, if RB value is given. So what you need, RB value should be known, RC value should be known, and what is the VBB I am supplying should be known, and VCC should be known, correct? But one that is known, automatically you can calculate IB. Once IB is calculated, you can calculate IC. Once IC is calculated, you can get this also. The supply voltage, that is collector supply voltage minus the low voltage across this resistor minus VCE, voltage across collector emitter term VCE is called as 0. This is called Kirchhoff's voltage. From that, always I can derive this, correct? VCE equal to, I want to find out what is this voltage, correct? This is called VCE. I want to find out this voltage I know, collector current I know, I can calculate VCE. Correct? In the exam, you may ask like this. Calculate VCE, calculate IB, correct? Calculate IC. Okay? Given what value? VCC is given, VB is given, correct? RB is given, RC is given. Correct? Then using the formula, you can calculate. Okay? Now, this already we are talking, quickly we will go through. Now, we are shown here how to bias. Without biasing, transistor will not work. No doubt. Without giving the bias voltage, this VCC and VB, transistor will not work. Okay. So if transistor has to work as amplifier, what I told, VBB should be greater than 0.7 volts. First thing. Then only IB will go. Otherwise, IB will be 0. Correct? If VBB is 0.7 volts or 0.6 volts, IB will not flow. Okay. That means you should give this voltage should be always greater than 0.7. It can go up to VBB max as mentioned by manufacturer. It can be 5 volts, 7 volts, 10 volts, or 50 volts, whatever it may be. Manufacturer says. Okay. Similarly, if transistor has to work, another condition also is there. VBB should be greater than this one, and VCC should be greater than VBB. Another condition. For example, if I give 5 volts here, VCC should be at least 6 volts. At least 6 volts. It should be greater. You cannot give, theoretically it should work, but practically it should be 1 volt difference should be no doubt. They say minimum 0.8 to 1 volt should be difference should be there between VBB, correct? VBB should be minimum greater than 0.7. For example, I say VBB equal to 0.8 volts. What should be VCC? VCC should be 1 volt more. That means 1.8 volts. So VCC should be greater than VBB always. Then only transistor will work as amplifier. What do you mean by amplifier? That means if IB is given, it will be multiplied by beta times. So IC will be flowing. Beta time IP will go. Then only I say that my transistor working as amplifier. Otherwise, it is not so. So 2 to 3 conditions are there. One is you have to give a base voltage VBB in NPN transistor, right? That are PNP both. Only thing of polarity. Positive of the VBB should be connected to base of the transistor through RB. Similarly, you should have a VCC power supply. Let me clearly you will see it. So the VBB positive should be connected to base terminal through RB. Similarly, VCC should be connected to collector terminal through RC, collector resistance, and emitter should be connected to negative terminal, both the transistors, both the power supplies. Correct? So this is called a common ground. That's why this is called as common emitter amplifier. I told you. Okay. And the most important, first we need a 2 power supply. Next condition is VBB should be greater than 0.7 volts. Then only IB will flow. If IB flows only, if IB is greater than 0, then only IC will flow. Then only I say my transistor working as amplifier. Okay. First thing. Then next thing is VCC should be greater than VBB at least by 1 volt. They say 0.78. Generally, as a thumb rule, you should take at least 1 volt higher than. That means if this voltage is 0.7, this voltage should be 1.8 volts. That is minimum to this transistor to work. But we'll be supplying, I told VBB will vary from 0 to VB max. Correct? For example, for this transistor, I told yesterday, BC107, VB max equal to 5 volts. That means this voltage be varied from 0 to 5 volts. When voltage is less than 0.7, IB will not flow, transistor will not work. So that means you have to give higher than 0.7. Okay. So that means you will vary from 0.8 volts to 5 volts for the BC107 transistor. That's what the manufacturer says. 5 volt is VB max. Similarly, that means if I give 5 volts, there is maximum voltage in the base, accordingly IB will vary. According to a formula what we saw. IB already we saw the formula. It will go. Then IC will flow. To flow that, what will be this voltage? You cannot give 1.8 volts. If you give 1.8 volts, what happens? My VBB is equal to 5 volts because you are supplied my transistor manufacturer. I can supply up to 5 volts. You are applied. Correct? 0.8, 1, 2, 3, 4, 5 increase. But if you keep the VCC equal to 0.8 volts, when this was 0.8 volts, that time VCC for 1.8 volts. 1 volt difference is there, higher voltage. Now, if I make this 1 volt, this is still keep it 1.8, difference is not there. If I make 2 volt, not possible. That means proportionally or to. So generally, what you will do is you apply VCC also. There's a voltage VCC max. Transistor manufacturers, what is the maximum voltage collector can be applied? So you can apply that much voltage. For example, for this transistor, they said 10 volts. So you keep it at 10 volts. Okay. Now this is varying by 0.8 volts to 5 volts. Even if you supply 5 volts, you can say the VCC you are keeping is constant. Generally, the base voltage will be varied because of this input voltage. Collector voltage will be kept constant. Okay. The output is not the voltage, the current. IB is the input, IC is the output, VCC is collector voltage is maintained generally close to VCC max. Okay. Otherwise, the collector voltage can be same as what is the load voltage. I am going to talk now. Okay. Load voltage will be equal to VCC. What is load voltage? We are going to see in a few minutes. Wait. Okay. Now that we have computed current, all those things, next thing you expect is you have computed RB. Now, how to compute what is the RB value? I said this is 1000. Take it as 1000 ohms. Somebody can ask, so why not 100 ohms? Why not 10 ohms? Why not 10,000 ohms? You can take anything. How do you decide what should be the RB? Similarly, I said this is RC. RC equal, I said 100 ohms when I'm talking. Correct? You can same question like RB you can ask. Why not 10 ohms? Why not 1 ohms? Why not 0.1 ohms? Why not 1000 ohms? You can have any value. Correct? But there is a rule. How much it should be? How will you decide? RB should be computed such that already you know what are the important parameter for a transistor. Again, I'm repeating, very important. VBB max, VCC max, IC max, IB max, and beta. For any transistor, these are important parameter. Correct? So there are more than, I said, 20,000 transistors of people are making, different companies. You can select any another based on your requirement. We are going to decide what is your requirement, how to select a transistor next slide. But right now, for a given transistor, I say BC107. Correct? This is transistor selected. I say VBB max is 5 volts. I don't know exactly. I'm just giving approximately. VCC is, for example, 10 volts. IC max is 100 milliamps. Correct? IB max is, for example, 5 milliamps. Beta, they said 100. This is already available. This transistor I have selected. This is my BC107. For this, how will you compute RB? How will you compute RC? That is what this formula. RB equal to, note down this formula. This is nothing but VBB. This is my VBB minus VBE. We know that VB is when VBB is greater than 0.7. We know that my VB is always 0.7. Whether it is 0.8 volts or 1 volt, 2 volt, 3 volt, this will remain constant. This will remain constant. But only condition is VBB should be greater than 0.7. Correct? That means 0.8, 0.9, what up to 5 volts. You can go up to 5 volts, but that's what BC 107, the manufacturer already told. You cannot give this voltage cannot exceed beyond 5 volts. You can vary from 0.0 to 0.5 5 volts, but transistor will not conduct up to 0.7 volts. Okay, that is the condition.
Sir,
Now,
I have a. I'm a bit curious.
Yeah.
So this 0.7 volts is standard across all
any
types of-
silicon transistor.
Yeah.
If you see the data sheet, it is made from the silicon material. If transistor is made from silicon material, it is 0.7 volts. If it is made with germanium material, base material, germanium instead of silicon, it is 0.2 volts, no doubt. But germanium is no more used. Now, for last 50 years, all electronic devices are made with silicon only. Other one is called gallium. For example, LED and all made with gallium. Okay. Well, LED, we are seeing those things. Gallium is the base material. From that, they make the N-type material, P-type material. But otherwise, 99% of the electronic devices, FET, transistor, SCR, everything is made with silicon. If it is a transistor, base to emitter conducting voltage, the 0.7 voltage is called as cut-in voltage. Note down. It is called as cut-in voltage of transistor. That is terminology. Is 0.7 fixed. That will happen only when the supply voltage greater than 0.8 volts. If supply voltage lesser than the VB is same. When VBB is lesser than 0.7, VBE is equal to VBB. Note down. If the supply voltage is lesser than 0.7, VBE, this voltage is same as supply voltage, this base voltage. Once the VBE is greater than 0.7, the VBE becomes 0.7 volts always. Even if you base 1, 2, 3, 4, 5, that is maximum. You take another transistor, tip 122, 0 to 10 volts you can give VBB. Correct? So 0 volts, 1.1, 0.2, 0.3, 0.4, 0.7. VBB equal to VBE. 0.5 VBE means both are same. But once VBE become 0.8, VBE become 0.7. 1 volt, 2 volt, 3 volt, 5, 6, 7, 10. Still VBE, this voltage is going to be 0.7. Calculation, no doubt. Okay. So RB value should be calculated. RB equal to VBB minus VBE divided by IB max. According to this formula, what is this one? RB equal to, I said VBB max. VBB max equal 5 volt. 5 minus 0.7 divided by, what is IB max I told? 5 milliamps. 5 into 10 power minus 3 equal to 4.3 multiplied by, this goes up, you've got 10 power 3 divided by 5. Correct? So this is going to be 200. Correct? 200 into 4.3 is nothing but 860 ohms. Correct? So my RB equal to 860 ohms. So this is how they call designing the amplifier. Finding the RB value. That is based on VBB max and IB max. Correct? Similarly, how will you find a RC? This resistance value, the formula is given here. Let me clear. You can see it clearly. RC equal to VCC max. Correct? I forgot to write VCC max minus VCE divided by IC. Okay. What is VCE value? VCE value equal to, correct? Already we have the formula. Note down this formula. That's why I given this formula. Correct? VCE equal to VCC minus IC into RC. Okay? This is what the formula. But at one particular condition alone, VCE become 0.2 volts. When, what is the condition? When IB max, IB equal to IB max. Correct? Then what happens? IC will be equal to IC max. In that condition, VCE is 0.2 volts. Correct? That condition when will happen? When my VB equal to 5 volts, automatically IB will be IB max. This is nothing but VB max. VB max. So IB max when flows to this will become IC max. What that is IC max is there. That time, if you supply VCC max, then you can find out what is the RC value. To find out RC value, how will you find out? At any given this one, always you say that VCC max minus this VCE. General formula is this, correct? When IB is lesser than IB max, no doubt, correct? In that condition, this is the formula you have to use. VCE equal to VCC minus IC minus RC to compute VCE, correct? But if you supply IB max, which is now 5 volts for the BC 107, IB max will be 5 milliamps. Already I told you. IC max will be 100 milliamps. In that condition, this VCE will become 0.2 volts. Okay. Then you apply this, then you can find our RC value. According to this, I said 10 volts I am applying here. Right. That is VCC max minus 0.2 volts VCE. Correct. This is called VCE saturation. VCE saturation. When IB is equal to IB max, which is 5 milliamps, IC will be IC max. That time, the voltage collected to emitter particle VCE sat is going to be 0.2 volts. This automatically invalid at one condition alone. That condition only you have to find a RC. You found what this one. So according to this, divided by IC max 100 into 10 power minus 3. What is that? 10 by this one is 9.8 divided by 100 into 10 power 3. I can say that 9.8 divided by 10 power minus 1. Correct? It is nothing but 98. Correct? So my RC value equal to 90. Okay, this is how you find out. Right? So you can expect problem. That's why I'm explaining for last 2 days. This is one of the important fundamental. This one for transistor as amplifier. Understanding very important. Okay, now that you have computed this one. So what I say, my RC equal to 98 ohms. The RB equal to, I think, 840 ohms something it came. Correct? And VCC equal to 10 volts. VBB equal to 5 volts. Correct? So now I have designed it to my transistor amplifier. Exam, in some, you can expect. I given VBB max, IC max, IB max, correct? Beta, and also given. I will ask you to design a NPN transistor based common emitter amplifier. That means you have to draw this circuit, correct? Then you have to compute the RB value and this one. This is one thing. Next thing, what in the same question, what will ask? What is the power dissipated across these two resistors? Correct? This resistor and this resistor and also across transistor. Correct? So power will be dissipated. Power will be dissipated as a heat. You can't avoid it. So how will you compute this one? The formulas are given here. PRB means the power dissipated across base resistor. Power dissipated across this is nothing but IB square multiplied by RB. RB resistance value multiplied by base current. At any given instant, IB will vary. Correct? If I say that IB, when calculate power PRB at IB equal to say 2.5 milliamps. Correct? Then I will say that's what I will give. Also calculate PRB and also PRC. PRC is power dissipated across this resistor. How will you compute? I give only one condition. Calculate power across PRB and PRC and transistor PTR. Note down the formula. PTR equal to VCE multiplied by IC. Correct? Again, VCE is equal to 0.2 volts only when IB equal to IB max. Correct? If any other value, VCE should be computed using this formula. VCE should be computed using this formula. You know IC, you know the RC. Correct? Already you computed. VCE, you know what is power you are applying in the problem given. Then you can compute VCE. This multiplied by this is called as P transistor. Correct? But at a special condition, at IB equal to IB max, what will happen? IC will be IC max and VCE will be VCE sat, which is nothing but 0.2 volts. Then what is the power transfer PTR equal to 0.2 into IC. Otherwise, you have to calculate VCE using this formula and compute. Okay. Now, IB is known, automatically you want to call PRC. To calculate PRC, what you do, you should know the IC. Already you know beta, already given beta, already you know the IB. So you can calculate beta time IB equal to IC. Then you can compute this power dissipated. Okay. So 3 formulas. Again, I am clearing this before going. PTR, I have not given, is nothing but VCE multiplied by IC. So these 3 formulas and these 5 formulas you should know, and how to apply also you should know. You can expect some problem and you have to draw the diagram, mention this RB equal to how much, RC equal to how much, and the supply voltage, all those things you have to draw, then you get full marks. Okay. Transistor amplifier over. Okay. This is what I have talked about is, in fact, we can talk about power dissipated across 2 things. One is one current is going to the, because IB between base and emitter there's a current going, correct? That is IB, and there's a voltage called VBE, correct? So this is called a power dissipated across this junction. Similarly, I said between these 2 you can compute. IC is flowing and there's a VCE. If you multiply these 2, 1 power is coming. If you multiply IB into VB, 1 power is coming. Actual full power dissipated across transistor can be computed at PTR equal to PBE plus PCE. Correct? PBE is nothing VBE into IB and PCE is nothing VC into IC. So you can expect this PBE, PCE total. That can be computed using this. Apart from computing power dissipated across base resistor, power dissipated across collector resistor. Any doubts you can ask now. Definitely there will be a problem in the exam. And we will have to draw this circuit also. And also we'll talk about what is bias voltage. Again, I'm just telling you, correct? In exam, what is the transistor? What is the bias voltage? Why you have to bias the transistor? Just now I explained, correct? You need to supply 2 power supply, VBB and VCE. Both should be DC voltage. You cannot be AC voltage. And what should be VCC max will be decided by manufacturer, VBB. Then only, and we know the VBB should be smaller than VCC. That means VC should be always greater than VB. How much? By 1 volt. Then only this one. By making VC is greater than VBB. What should be minimum voltage VBB? VBB should be minimum of 0.7 volts, which is called continuous voltage. Then only transistor as a transistor amplifier. Why it is called amplifier? Because IB, which is called input current, is amplified by beta times. That's why it is called as amplifier. Correct? These are key points also you have to explain. Any doubts? Because next class I am not going to repeat. I will go to, because we have to go. We have another 9 classes only. Not 10 classes only. Each class I will be going. But I am explaining. Any doubt? Now itself ask.
No problem, sir.
Yeah. Yes, please. Somebody ask something.
No, sir. I will. Everything is okay, sir.
Model some.
That's what I explained now.
Yeah. It's
The water model, because we cannot, otherwise cannot cover. So already I explained everything.
right.
Models only today I explained. Otherwise, today I should have gone APAM. Okay, I'll stop here. Tomorrow we'll see operational amplifier, which can be used as an amplifier instead of transistor. Correct? That we will see tomorrow. See you tomorrow. But already 7, that is 5:55. Other teacher, I don't want to make him to wait. Okay.
Okay, sir. Tomorrow, sir. Tomorrow class is
Yeah, tomorrow we have class 5 to 7.
right, sir. Thank you.
Tomorrow I want to complete 1 syllabus.
Right, sir.
APAM amplifier and filter circuit. Both will be covered tomorrow.
Right, sir.
Okay.
Thank you.
Thank you. See you tomorrow. Give you attendance before leaving. Good luck.
Thank you, sir.
Okay.
Thank you, sir.